Learning about security doesn't need to be scary.
If you want to ship code securely with confidence, check out the URL below and challenge yourself with thousands of challenges in 29 coding frameworks. Let the games begin.
So we've got Eldar coming up, talking about some vulnerability stuff, and is it an interactive session, isn't it?
Yes. Audience participation required.
Mandatory, I think you said before. So when the slide comes up, here we go. I was going to say thank you very much to the sponsors. But then the slide's not up, we'll just leave it like that. But let's give a round of applause to the sponsors for today. Without it, we can't really run this thing. So, and let's give it up for Eldar, who's flown over all the way from
Abu Dhabi.
There we go. Thank you, Eldar.
Thank you. So there are some companies that do challenges like this, that present you with a bit of a code, see if you can spot the vulnerability. That's essentially what we're doing today. I'll show some code. I'll explain what the problem is. But before I do, I'd like you guys to have a guess. And there's Smarties for the smart people who get it. I was trying to get, bug-themed rewards because there was Halloween. I was like, can you get bug candy? That would be cool. Because we were looking at bugs. So, anyway, a little bit about me. I started my career as a developer. I've been a sysadmin, pen tester. I'm currently a security researcher, married with kids, and I also run training at some cons like this con. Some simple rules, just a bit of housekeeping. There's only intended to be one, hopefully, obvious vulnerability per slide. I mean, there could be more. I know that some of them, you might recategorize, but hopefully it's intended to be so obvious that you know which one it is. I try not to repeat vulnerabilities. Some of the tangible stuff, I guess, get repeated. So try to do minimal context so you don't have to read, 50 lines of code per slide. Ideally like 5 or 10, 15 at the most. I don't have informational risk. These are actual vulnerabilities with impact. One caveat. Anyway, I also had don't yell at the answers because I actually was expecting a relatively smaller room, but it's a bit of a run around with the microphone, so just yell it out. Luke, he enjoys the exercise anyway. All right, and like I said, reward for audience participation. And so that's it. We'll see how many. So hopefully, I should be able to get through all of them. So we'll just start by spotting some vulnerabilities. No warm up, no nothing. Anyone want to have a guess at what's going on here? No. Sorry? Cookies. Cookies? Cookies is functionality. Specifically vulnerability? Nope. No. Sorry, what was that? Yes. So, Luke, good work. We are doing a redirect based on the header, but we don't halt execution with an exit. And so even though the page will redirect the browser, the code for factory reset will still load and execute. So it's an authentication bypass or a failure to halt execution, because in this case, the check for session is intended to verify that someone is authenticated and authorized to do so. So that's essentially how all of these are going to go. So when you're yelling from up there, just yell a bit louder because I'm having a hard time hearing you. All right, moving on from PHP to Python. Now this one is an actual real-world vulnerability. It's a bit of a tricky one. Sorry? No, it's not time-based.
Is it to do with nil?
Nope, not to do with...
Will it log the password if it fails? Exception.
Yes, half right. Python will remove assert statements if run under optimization. So this was in a SAML implementation for a Python library, and someone was kind enough to open a issue for them on GitHub. But essentially, if you were to run your Python app using this framework with optimization, then the assert goes away, and the entire verification just does nothing. You could also argue that having it, not having like a specific return, true, false, else condition, but simply relying on we will, terminate execution with an assert if it doesn't match. Maybe a little bit different. So, right. So we've done 2 languages. Let's do another one. .NET or C#. Yeah, insecure direct object reference. We got someone running this up. Essentially, it checks that you have a role, but it doesn't check that the account ID belongs to the active user. So you have to be authenticated / authorized to access this functionality, but then it's not limited to only seeing your account. This is a staple in bug bounties. Right, back to PHP. I love PHP. It's so full of badness.
Missing a parenthesis.
Okay, yeah, sure, I am. That's not intended.
Passing an URL as file name?
Sorry?
That's vulnerable to getting an URL passed in as file name.
A URL? Partially correct. I think we're going to finish pretty early, guys. Right. So specifically in PHP, there's something called stream wrappers. So you can do more than just URLs. You can access SSH. One of my favorite one, but you never see it in the wild, is there's an expect wrapper, which is based around the old Unix tool, command line tool, expect. And that one is particularly fun because expect ignores a lot of the PHP config. So even if you say, don't allow file open on URLs, expect goes YOLO. Yeah. So even though you configure PHP to don't do certain badness, then the expect plugin just comes in and does it anyway. The other one that's been relatively popular recently is the use of a FAR file. So the FAR format supports deserialization within that, and you can lead to code execution. However, you would have to be able to put a file on the file system. And the thing that really trips this up is it's all sorts of functions you would generally consider to be safe. Checking for whether or not a file exists is generally not considered something that will lead to remote code execution, but PHP. Here we go. Bit of Java. Deserialization. Woo! Super. Really quick. Yeah, the bane of Java, and to some extent PHP. Was it just because I said deserialization in the FAR file before that you... Or is it just, it's Java, it kind of has to be deserialization, and either one defaults to. So essentially, for those who don't know, serialization and deserialization is taking an object, converting it to a tokenized string, which can then be returned back into an object with the same sort of state in memory. And they, in all the languages that support serialization, it tends to come with security clauses. Now, I don't know every language in the world, so there might be one that does it right, but as a general rule, it's an item that you should look at. or look for. Sorry? Yeah, like I said, one is meant to be the intended, very obvious one. So a lot of like the ones we've seen before, the PHP ones, like they don't have CSRF protection or etc. So it's it's kind of hard. It's kind of hard to do one that's that only has like one very narrow vulnerability, because you might want to add a little bit more context, and as soon as you chuck in a few lines of code, you might have more than one sort of condition. All right. Long piece of JavaScript.
Cross-site scripting.
Cross-site scripting, who was that? It's dumb cross-site scripting, to be specific. That's correct. So essentially, it rewrites the location based on content that the user controls. You give it a JavaScript URI, and it executes the code. All right. Right. PHP again.
Local file inclusion.
Sorry?
LFI.
Local file inclusion. That's the one. Now this one is a little contrived, because normally you'd have usually an extension on there like .php. Doesn't alter the vulnerability classification, but it could make the path to exploiting it a little more difficult. Now, local file include is a bug class that I often get frustrated with people for, because people will call things that are not local file include, and it's sort of a pet peeve of mine. It's called local file include because it's a local file and it ends up inside an include function. The include function will read the content of the file and execute it. So you're not just returning files from the file system, but you are executing code. And so the simplest way of doing that is either placing a file on the file system. In the case of web applications, that might be a little bit hard. But Linux in particular is kind of helpful in terms that it has procfs, which lets you interact with processes as if they were a file system. So you can read the environment variables for your process from proc self environ, and the environment variables stored in that for a web application will contain content from the browser, and this is because of the old CGI interface. That's how you get the data from the HTTP request into the script that's executing. So very simply, sending a crafted request with a bit of PHP code as the user agent string, and then loading proc self environ, you execute that PHP code. All right, .NET again. Yeah, I think there was like 3. All right. Now, this one only affects older version of the entity framework. And the reason why it works is the from SQL had 2 different definitions. So if you didn't provide the query as like a variable, it would craft a parameterized query and it would be safe. But if you provided it as a variable, due to overload, it would use the other from SQL function, which was vulnerable. So even though you call the same function name, you could have very different behavior. It has been fixed since, I believe, Entity Framework version 2. You can correct me if I'm wrong, but yeah, I don't really do a lot of .NET. All right, none of you in the front row. Nope. We are calling base name, so there is no traversing. No. Anyone else? I'll take it from the front row. Arbitrary file upload. we are not validating the type of file. So, and also the target path is a subdirectory from the PHP script, so it's actually within the web root. It could be password protected, blah, blah, but context is missing. And yeah, the attacker just applies a PHP script. It gets stored inside the web root. You then go to upload filename.php, and you're executing PHP code. Also not from the front row. Yeah, XXE. So the create XML stream reader function will parse XML, and it will process external entities by default. Now you can rejig the object with the configuration parameters that will stop this, but by default the behavior is insecure. Yep. I think there was one there too. We are explicitly turning off SSL validation. So depending on what the data is being accessed, this may be significant or less significant. That is the side effect or the end result, but that's not type juggling. Was that there? Yeah. Type juggling. The reason why is we are using the double equal comparison. So PHP will gladly take a string starting with 1, 2, 3, but also containing a whole lot of other information, and say that actually matches 1, 2, 3. Because it converts the string to an integer, which drops all the extra text. But then when it gets used again in the SQL statement, it is treated as a string, so all the additional information is in there. So yeah, SQL injection is what comes out of this. But if this had been done with the triple equal operator, then it would be safe, even though it follows the rather unsanitary approach of concatenating superglobals in your SQL statement. Don't concatenate your superglobals just in strings in general. Do input validation properly. All right, CGI scripts. We're back to the 80s. Sorry?
That doesn't actually validate.
Yep, we got the back there. It just checks for the presence of a CSRF token. Now that will often be enough to stop scanners from sort of being able to access things, but you can just put whatever you want. You can reuse an old CSRF token. Just overall, it's bad practice. And how are we doing for time? Okay, not too bad. All right, super simple sample. Yep. And this is like another staple from. You want some more? Nothing there. All right. The reason why is PHP Self is a meta super global variable that has, I guess, not necessarily expected behavior. So In most normal use cases, it will only contain the path to the script, but there are other circumstances, such as the use of path info, that can contain special characters. And so you can access a / sort of directory after the PHP file, even if it doesn't exist. It still executes that PHP file, and it appends all of the path info into the PHP Self. So when that gets echoed back out, you have the special characters. And it's also not URL encoded by default, so it's kind of handy. Well, depending on the browser. But. None of you. Command injection. So the file name is not being checked. So there are, depending on sort of the context, there's two things. One is you just give a file name that doesn't exist that contains syntax to inject a command. However, even in cases where it does check that the file exists, on certain file systems, you're allowed to have file names that contain syntactical, such as semicolon uname space -a is a valid file name. All right. Here's another real-world vulnerability. I can't hear you. Assume context. Yep. Privilege escalation or account impersonation. This is a real-world vulnerability too, which I thought that was really great. So there's no check to see whether or not. In this case, there's no authentication checks either, but you can assume that that one exists along with the session start function. But it just trusts whatever's being provided as the username. In this example, the actual real-world vulnerability, this functionality was intended for administrators to be able to impersonate other users, so you can sort of see what would my website look like if I had these privileges, or you sort of test functionality from different user groups or privileges. However, you could reach this function as a lower privileged user, so you just set your username to admin, and off you go. Here's a fun one. Like squinting at squiggly characters. Yeah, who's that down there? Yeah. Thanks a look. Why though? Did you spot where it is, or did you just guess? Yeah. Yeah, big regular expression, regex DOS tends to be sort of the logical explanation. So again, this is a pretty common regular expression that was meant to validate emails. And so we can see here it actually does character sequence incrementation inside a group that is inside another group that is also iterative repetition. And because of the way the greedy matching in regular expression works, it'll first try to match as much as possible and then start walking back. So it actually processes the content within a string repeatedly, multiple times over, as it tries to adjust the best distribution of the different groups of characters. So you provide a very long email, or not necessarily very long, but reasonably long email that is valid to this function, and the CPU usage just goes through the roof because it's walking the string back and forth hundreds of times. Regular expressions in general have complexity that makes them bad for performance. Everyone knows what Twig is? Yeah? Sorry? Template injection. It's the same guy. You have enough? Yep. So the template, or the twig template framework in this case, operates on user-supplied input. You inject malicious template, and you get shell. Right, we are actually almost done. Like half the time. You guys are too quick, too good. Sorry? No, it's not hard-coded password. Although, huh? Yeah, no, it's not that one. Sorry? Information disclosure, yes. This is the one exception that I have for informative error, or stack traces do not belong in web application, they belong in logs. Or thick client applications, whatever. Log that stuff, don't print it out. It's actually pretty funny. If you go and Google stack traces, you'll find stuff like this, including like the username and passwords used to connect to the database, just sitting in the Google cache for your application. So they do actually have real-world impact, but they're usually pretty boring from a penetration testing perspective. They're only fun if you can use them with something else. This might look familiar, but it's not SSL validation this time. Yeah, at the back there. Server-side request forgery. Server-side request forgery is somewhat similar to client-side request forgery in terms of you can you make something make a request on your behalf, but the difference is this is not attacking a client or a browser. It is making a web page or a server make the request on your behalf. The fun thing that you do with this is usually you try to access AWS meta variables or some sort of useful URL, which will give you access keys, usernames, passwords, etc. But you can also use it for things like port scanning, depending on which library, in this case curl. You can supply usernames and passwords plus services, so you could like brute force internal accounts by hitting an FTP server with the username and password in the URL from this. They're pretty handy. Also, a very popular bug class with people who do bug bounties. Sorry? Path traversal, or directory traversal. So in this case, we get the user-controlled file name, no validation, and then just recover that file. So it's meant to be relative to where the script is running, but you can just ... slash your way out to etc password. And this is the last one. Yeah. Where is the admin control? Just, if you have a super secret admin function, you probably don't want anyone but admins running the super secret admin function. So it's missing a privilege or authorization check in that code. There's also one of the neater, or the type of bugs that I enjoy looking for, because generally you can't run a source code scanner on this, and the source code scanner won't be able to determine whether or not this is intended for public use or intended for privileged use, and so it can't detect that lack of authentication isn't there. All right, so that is it. A lot quicker than I anticipated. But there's some spare Smarties around if you feel like having some more chocolate or sugar, and I think Luke will do some entertaining for the remaining half hour. Otherwise, feel free to pop around and say hi, have a coffee or something.
Awesome. Can we have a round of applause for that? Thank you very much. My microphone's
He said thank you very much.
Oh, yeah, yeah. Oh, here we go. I'm back, yay. Yeah, so thank you very much, Eldar. That was really good. I wonder if we have any questions in the audience. I have one.
Yeah.
Oh, yeah. What would be your favourite one of those bugs, or the favourite bug class, you think? And then the type, that one that you see the most in recent history?
The one I see the most, I guess, is probably the failure to halt after redirect. It's super common in PHP, so you find you combine that with like an SQL injection, and then you go from authenticated SQL injection to just unauthenticated SQL injection. In general, all of the ones that will give me shell are like my favorite. If they don't give me shell, then they're not so fun.
And it seems as though a lot of these bugs that you found as well, that wouldn't be found by any kind of source code scanning tools or anything like that. It's usually found in a pen test or maybe dynamic analysis of the source code itself.
It depends on which ones they are. Things like the SSL validation is like super easy to find with even like grep. But things like template injection pretty much has to be, it could be dynamic. It depends. Different. The context matters, but overall, they do complement each other, and there is some overlap. But obviously, there are certain things like, particularly, and it's not in here, but like second-order injections and stuff. Like it has to be dynamic. There's no way to necessarily, or either that or you read a lot of code.
All the tools really, really good.
Yeah.
Very expensive as well. There is one question. Fantastic.
Yeah.
So if we have to perform a secure code review on an altogether new application and you don't know the language at all and you have very limited time, then where do we start and how do we go about it?
You go to my GitHub and you grab Grawdit and then you start there. Generally is some sort of scanner that'll run through the code. It'll read it a lot quicker than you as a human can, but you got to, I guess, start somewhere, right? The other thing I tend to say is don't just rely on automated tools, because, like we saw, the lack of authentication checks, etc., that will not be found by these tools. For things that are like critical components, like maybe your OAuth library or framework, etc., get some eyeballs on it, read it top to bottom, maybe have more than one person read it. But it's probably better off implementing code review as a standard process as part of development, rather than do it all and then expect to cram in reviewing 800,000 lines of code in a week at the end.
It's never fun. Were there any other questions in the audience? Oh, one down the front here.
Hey, it looked to me that most of the vulnerabilities you presented are actually some sort of bug, lacking authentication or just the wrong logics. And understand that there's probably a fine line between what's a vulnerability and what's a bug, and you can consider one to be the other. Yeah. So how do you see this? Because those are things which are some of them you can take from code review rather than proper vulnerability analysis or even pen test.
Yeah. You're asking me to define what vulnerability is. Essentially, the short version is, I guess I'd say that it carries some inherent risk, or it can be attributed to perform an action you didn't intend. Would typically be the two things I would say that contributes to it being a vulnerability rather than just a bug. But it's mostly, I guess, defined based on doing a risk assessment of the actual bug to prove that it carries a risk, and if it doesn't carry any risk, then it's just like a QA bug. However, even then, QA bugs, it could potentially be like a denial of service, right? If you can stop it responding. So yeah, you have to give it context. You have to obviously weight things like is it publicly accessible? Is it locked? Is it on a computer that's locked in a basement in a room where only one person can access by climbing over a moat of alligators or sharks with lasers on their head? Risk is contextual. So, but I guess I mostly rely on experience and past taxonomy.
I think there was one more question as well. Did I see someone else with their hand up? Oh, over there.
Thank you. So I heard that when you try to secure application, you have to think like the attacker. But how do you actually know, or in a larger web application, that there is just one endpoint that forgot to do this check? How do you get there? I mean, it's pretty weird, I think.
Really depends, is the answer. Start by looking, I guess. If you don't try to determine whether or not you have any exposed vulnerabilities, you'll probably never find them, or you'll find them when somebody emails you saying, "Please give us bitcoins." But other than that, it's how to do test coverage and stuff is probably a little bit outside of this. But yeah, start by looking, and then I guess try to improve on your process for finding. Hire Luke or someone else to come in and mess up your network.
Anytime. No, Tanya did that presentation this morning around if you've gone through previous iterations of penetration tests, find out what the bugs were in those ones, and then maybe create a test case out of those and use those against the new code or maybe different code, and who knows what might pop out.
Yeah.
Oh, another one.
Yeah. So, what is an ideal way to start off with manual code reviews? Is it control flow, starting with control flow, or data flow? Or sometimes I just confuse and I just go here and there. Please say something.
I think it would depend on how your development lifecycle is run. If you use pair programming, you have code review sort of inherent in a second pair viable on your code as you're typing it. But I guess for most agile and newer, I guess, development practices, you can do just basically code review requests in GitHub or GitLab or what's the Atlassian one? Bitbucket. So you can usually have, I guess, two approaches. One is the developer mandates. They ask, "Hey, I've written this code. I think it deals with sensitive data. I want someone to look at it," and they just request a code review through your tools. And the other way is to have it mandated, I guess, through management that for every something event, every 30 days or every release or every branch merge or whatever you decide, someone has to come in and look at it. And then, of course, you can always just do commit hooks for things like automated scanners, like SonarQube with Travis, or it depends on where you are and what works for you. Regulation. So depending on where you are, like if you're dealing with PII or credit card data or whatever, then it's different as well. So
whichever way we choose, but still, when we are actually getting into the code, and when we have to, let's say, you're just using grep and finding some functions, sensitive functions or things like that. And when you start, is it better to go with control flow of the application or the data flow? What is the weightage that we give and how do we go about it?
Ideally you want to do more than one approach, but it's certain things work better for certain languages. Certain developers have an easier time spotting stuff. I think both Atlassian and Google have written some pretty good posts on this, and like how to do code review, how do you implement it, how do you go from we never have time to do code review to actually implementing it as part of your ongoing life cycle. I think Atlassian has conference presentations and stuff. Probably start there and then see what can be adapted to you. Yeah.
Righty, were there any other questions? Alrighty, can we give a massive round of applause to Eldar? That was great. Thank you very much, mate. Very fun.